So on your diagram, hopefully you know which electrode was hooked up to which. What should be true about the mass of copper increasing here compared to the mass of the copper electrode on the other one? It should theoretically be equal, right? Does that make sense? How should that compare to the mass change for copper here? This copper mass increase and this copper mass increase, what should be true about those?
Be the same, right? Because it's the same current.
Okay, same current. Do you agree, as Eric says, that the mass increase of this copper electrode should be the same as this copper electrode? Yes? Do you agree with that? Okay. How about your zinc? Increase versus decrease. What should be true about those?
Same.
Those should be the same. All right? What about the mass change for zinc compared to the mass change for copper? What should be true about that?
Shouldn't copper be more?
Why?
Because zinc is oxidizing, but then I guess the electrons are showing it to be the same.
Well, they
Okay,
have
so
different
Manny
formula
says that the
masses.
mass changes for zinc are the same as the mass changes for copper. Eric, what do you say?
They have different formula masses. So like the change in moles would be the same, but the change in mass would be different.
Oh, so the mole changes are the same, but you're saying formula mass makes the mass changes different?
Yeah.
Oh, does that sound logical?
Yeah.
Okay, so if you take a look, folks, at number 4 and number 5, the first 3 questions are the same. What's the mass of copper dissolved? Or moles of copper dissolved, moles of metal deposited, and what should be true about them? All right, so you're going to answer those questions for each metal. And then the last question in 5 is, how should they compare to the number of moles of, and rather than copper, you can substitute in your other electrode metal. And we just finished talking about that, would you agree? So now you have the tools to answer that question as well. Okay? 6, we figured out how many coulombs of charge were transferred. And we calculated the current, that's 7. Then the second part of 7 is it possible to measure this current? Why do you suppose that question was asked of? When you use the 2 meters, the voltmeter and the ammeter, did you get a voltmeter reading? Listen to the question. Did you get a voltmeter reading? Okay, I see heads nodding. Did you get an ammeter reading? Okay, so once you calculate this current, that may make more sense. And if you took a look at the ammeter, we found that we could really only read to about 0.01 amps. So it's a little current, and so if your current was less than 0.01 amps, would those meters be able to measure? Okay. So thus that question. Does that make sense? Okay, number 8. You're just doing comparisons and explaining relationships. Last thing is number 9. You're calculating not E0, but E for the cell. Is E0 the same as E for the cell? Why not, Mackenzie?
Isn't E0 like the initial?
Not initial, but what does that 0 stand for? What is the 0 stand for? Standard, there we go. So, I don't have standard conditions, why not?
You're not using 1 molar solution.
I'm not using 1 molar solutions. So I need to figure out the E for my cell. I need to use the E0 to get there. Remember the equation? Good old Mr. Nernst gave it to us.
E0 minus
E0 cell minus
0.0592 over n times 1.
times log of Q. And any questions on how to find Q? Yes, no? Yes, Mackenzie?
Is it just the polarity of or the moles of your
Do you have a balanced electrochemical equation for number 1 for your galvanic cell? Okay? What is it? Let's take a look at yours. What are your two metals?
Aluminum and copper.
Good. So, what oxidizes, what reduces?
Aluminum reduces and copper oxides.
I asked you. What's the difference in zero for yourself?
For E0, you have to rate.
Okay. So, what's the equation?
Yeah, copper 2 plus aluminum goes to copper plus aluminum 3 plus.
Almost. What do you need to do with that? Nope.
Now,
Balancing would be a good idea, don't you think? Don't we usually balance our chemical equations? So, how would I balance it?
Well, I would think add 1 electron.
I can't. I never have electrons in my chemical equations. So, how would I balance this, Mackenzie? Oh, I bet you know how to do this. Right now, your atoms are balanced, correct? What about your charges? Are they balanced? How are you going to balance charges? Without adding electrons.
here's the proportion of copper.
Rachel, help her out.
You put 3 in front of C plus and 3 in front of C, and then 2 in front of Al.
Okay, when you wrote your two half reactions, Mackenzie, and you flipped the aluminum one to show that it was oxidizing, then you had to, before you added them together, make sure that the electrons were the same number in each half reaction, correct? Which is where you multiplied one by 3 and the other by 2, correct?
Yeah.
Then you add them together.
Yeah.
That's how we get a balanced equation. Alrighty? Okay. What's N for this particular reaction, by the way? 6. This is how many electrons are moving in that equation now? 6?
Yeah.
Okay. So, how do I find Q now, Mackenzie? No. How do I find Q? Remember what Q is? Oh.
This is just like the
What do we need to find Q, folks?
subject concentrations.
No, we did not figure out it was 4. You're making this way too hard, ladies and gentlemen.
Concentrations.
Concentrations! Oh yeah! Concentrations is the initial equilibrium concentration constant, right? So, what are my concentrations to start with? They were all what? 0.2. Copper was 0.2? No, it wasn't.
Copper was 0.2.
Okay, copper was 0.8. So, how do I write Q? What goes in the numerator of an equilibrium expression? Thank you. Which are what concentration? What are your products? 0.2. Okay, so aluminum ions are in the product side. Their concentration, 0.2. So I've got 0.2 molar over 0.8 molar. Are we done? So 0.2 gets what?
Square.
Really? Okay, squared. What's my coefficient here? 2, so squared.
Yeah,
And this is
third.
cubed. All right? So then you can figure out E, because this all goes there. N is what for this one? 6. I figured out E0 for the cell. Now I can find out E for the cell. And I compare E for the cell with what I measure.